All right, well, welcome back. This is day 2 of the notes, or well, like video 2 of the notes. If you're doing them one a day at a time, it's day 2. But section 2 of the notes for Unit 9, we're going to be talking about what are called reference and coterminal angles today. So reference angles, the definition of that, it is the acute angle which is formed by the terminal side of an angle and the x-axis. So when you're thinking terminal or reference angle, you want to think about what is the shortest possible distance to the x-axis. Let's say you were looking at an angle of 135 degrees, so something right here. Then what you would want to think about is from the terminal side of the angle. And remember, terminal side is this side where the angle finishes. What is the shortest possible way to get to the x-axis? And that shortest possible distance is this distance right here. That would then be the reference angle. We'll do some practice in just a little bit with how to find that. In addition to talking about reference angles, we're also going to talk about what are called coterminal angles. So coterminal angles are two angles whose terminal sides coincide. To give you an example of what that would look like, let's say you were maybe looking at some angles in standard form. For example, let's say you were looking at a 30-degree angle. So something about right here. If you think about it, a 30-degree angle is also the same if you go around the other direction as a negative 330-degree angle. If you think about it, they're the same exact angle. They go in the same exact place. They end the same place. The only difference is in which direction we measure them. So coterminal angles, two angles where their terminal sides coincide. So first, let's get some practice with reference angles. So with reference angles, we're going to look at what is the shortest distance that the angle makes between its terminal side and the x-axis. I'm going to be sketching most of these. I would encourage you to do the same. Eventually, you'll probably get to a point where you'll notice that you don't have to sketch it anymore. But until you get to that point, sketching it's never a bad idea. So let's start with our 30-degree angle. So when you think about a 30-degree angle, you're in your first quadrant. And so you're looking at an angle right here, which also happens to be your reference angle. So your reference angle for 30 degrees is 30 degrees. In fact, all angles that lie in the first quadrant are usually their own reference angle. And that's the only time that it can happen. Let's take a look at another example. So now let's take a look at 260 degrees. So when you sketch a 260 degree angle, you're going to line somewhere in this third quadrant, because if you think about down here is 270 degrees, so then this would be your original angle. So you're looking at what is the shortest distance between this side and the x-axis, which actually ends up being this distance right here. And if you think about what that's going towards, that's 180 degrees. So if you take 260 degrees minus 180 degrees, you'll end up with 80 degrees as your reference angle. Okay, let's take a look at another one. So on number 3, negative 135 degrees. Just a reminder, when you're doing negative, you go in clockwise direction, but all the angles pretty much stay the same. And so for negative 135, halfway between negative 90 and negative 180, you're looking at this angle right here. The shortest distance then between that angle and your x-axis is the distance between that angle and negative 180 degrees. And since we're talking about distance, the negatives don't really matter. So we'll just take 180 degrees minus that 135 degree angle to figure out what the difference was, and that ends up being a reference angle of 45 degrees. All right, one more in degrees, and then we will, we'll just one more in degrees, and we'll start looking at some ones in radians. So 460 degrees. We're going to measure that first. So remember that that would have to be past 360 degrees. So if you're thinking about that angle, we've already gone around once is 360. Then we have to go another 100. So that would be a little bit past 90 degrees here, That would put you right about here as far as where your angle would fall. We then need to look at what is the distance between the terminal side and your x-axis. That would be this distance right here. So if you think about it, what we talked about was this angle went around 360 plus another 100 degrees. We're looking at how much further would we have to go to get to 180. So that would be 180 minus 100 is a reference angle of 80 degrees. In fact, I don't know if we had this in the definition. I'm going to add this right now. But all reference angles have to be between 0 degrees and 90 degrees. And when we talk about angles, we usually use this Greek letter theta to say angle. But all of our angles have to be between 0 and 90 degrees. Cannot be more, can't be less. Okay, I'm going to skip over number 1, part 5. That would be very similar to number 3. So if you wanted to try that one on your own, you can. But I don't want it to be too repetitive. All right, let's take a look at radians now. So with radians, you've got pi over 4. So let's just a reminder of what the angles look like. So remember 0 and 2 pi is here. 90 degrees is pi over 2. 180 degrees is pi. And 270 degrees is 3 pi over 2. Now it would be probably more helpful if they were with a denominator of 4. So if you think about it, pi over the 2 is the same as 2 pi over 4. Pi would be the same as 4 pi over 4. And 3 pi over 2 would be the same as 6 pi over 4. So if you think about where pi over 4 would be, that would have to be halfway between 0 and 2 pi over 4. And so if you think about it, what that means is that it's also its own reference angle. So the reference angle on number 6 is also pi over 4. Okay, let's take a look at number 7. So let's set it up same way. We'll start with just our basic angles. This time we're going in a negative direction though. So negative 90 is the same as negative pi over 2. Negative 180 is the same as negative pi. And negative 270 is the same as negative 3 pi over 2. But again, this time we want them in terms of pi over 6's. So negative pi over 2, that would be the same as negative 3 pi over 6. Negative pi would be negative 6 pi over 6. And negative 3 pi over 2 would be negative 9 pi over 6. So a negative pi over 6 would be about a third of the way from 0 to negative 3 pi over 6. And so if you think about what that distance would be, you're in your fourth quadrant, but the shortest distance is still this distance right here. And that distance, even though the angle was measured as negative pi over 6, the distance is a positive pi over 6. So that would be your reference angle. All right, let's take a look at number 8, and then we'll probably do number 9, and again, number 10, probably skip over that one. So on number 8, let's again start by just graphing out where our angle would be. So for negative 2 pi over 3, let's think about our negative angles for radians. So again, you start with negative pi over 2, negative pi, negative 3 pi over 2. And again, I think we saw an example of this in the previous section. You're not going to be able to get your denominators to all be 3's, which is what you'd want with negative 2 pi over 3. Instead, what you'll have to think about is, what can 3 and 2 both go into? And somewhere 2 over 4, I think that's going to be a 6. So let's change all of these to being fractions over 6. So negative 2 pi over 3 would be negative 4 pi over 6. And then we can go around our circle and do the same. So negative pi over 2 would be negative 3 pi over 6. Negative pi would be negative 6 pi over 6. Negative 3 pi over 2 would be negative 9 pi over 6. And then we can sketch our angle. So negative 4 pi over 6 would be just past negative 3 pi over 6, somewhere kind of right in here. And so your reference angle, if you think about it, is going to be this piece of the angle between our terminal side and the x-axis right here. And remember, you've already gone negative 4 pi over 6's. So to get to negative 6 pi over 6, you would have to go 2 pi over 6's more. That's your reference angle. Let's do one more. In fact, I'm going to skip number 9. So this would be one to do on your own if you'd like to. Let's go and do number 10. So number 10, we're going to do 15 pi over 4. Let's start by just doing our basic measures. So you've got 0 and 2 pi here. This is pi over 2. This is pi. And I did those in the wrong order, didn't I? Pi over 2 should have been up here at 90. We just done so many negative ones, I got mixed around. So yeah, and then this would be 3 pi over 2. So this time, getting them to all be over 4, that's something we can definitely do. Pi over 2 would be the same as 2 pi over 4. Pi would be the same as 4 pi over 4. And 3 pi over 2 would be the same as 6 pi over 4. Once we've done that, and I guess we can go ahead and do 2 pi as well, since we're going to actually end up using it, 2 pi would be the same as 8 pi over 4. So when you're doing 15 pi over 4, all the way around once is 8 pi over 4. And then you want to go around again another 7 pi over 4 after that. And if you think about it, 7 is exactly halfway in between 6 and 8. And so then your reference angle, the one that's got the shortest distance between your terminal side and the x-axis, is right here. And if you think about how much more you'd have to go, which is a good way to think about it, you've already gone around another 7 pi over 4 in this second rotation. You only need to go another 1 pi over 4 to get back to 8 pi over 4. So 1 pi over 4 actually ends up being your reference angle. Okay, so that's reference angles. That was one of the two that we were going to talk about in this section of the notes. Next thing we're going to do is we're going to talk about coterminal angles. So coterminal angles, remember from our definition, were two angles whose terminal sides coincide. In other words, it's the same angle but measured maybe differently. So let's start by just kind of thinking about kind of what we're going to do in order to find those angles. So with 60 degrees, if you think about kind of where that would be kind of up here, measured between 0 and 90 degrees. One thing you could do is you could go around and measure that in a negative direction. So if you think about going in a negative direction, instead of going 60 degrees, for going around the other way, that would be negative 300 degrees. Which it did ask us, I believe, for one positive and one negative angle. So negative 300 degrees would be one angle that is coterminal. But it also wants another positive angle, and you may not see kind of what to do with that yet. Here's what you could do though. If you think about it, once you're at 60 degrees, so once you're right here, you could just go around one more time. And if you think about what going around one more time would be doing, that would be taking 60 degrees plus another 360 degrees would be 420 degrees. So there are your two coterminal angles. So if you notice what we did, really what we were thinking about was by adding 360 degrees, you could also have done the same by subtracting 360 degrees. So when you're in degrees for coterminal angles, we're going to add this to our definition, you'll just take the measure of your angle theta, and you will either add or subtract by 360 degrees. Now, the general formula is to put a k after it, meaning that you could add or subtract by that 360 degrees multiple times. In fact, we're going to see some examples where we do have to do that multiple times. So k represents the number of times that you add or subtract by 360. And when we do that, we're doing it a whole number of times, so k is always going to be an integer. And that is something that you want to be in the habit of writing, is that k represents an integer. You can also write that using a slightly different notation and saying that k is an element with this kind of e, meaning to say an element of, and then this kind of bolded z is the integers. So you can either write out k as an integer, or you can use this shorthand way of saying that. Okay, so let's try our formula, because that'll actually make things quite a bit easier. So what our formula said is that we can take negative 150 and we can subtract 360 degrees from it, meaning that negative 510 degrees would be coterminal with negative 150. It also said that we could add 360 degrees to it, and then that would tell us that 210 degrees is also coterminal with negative 150. Now I think it also wanted us to give the formula for all possible should have said coterminal angles. That was a typo. And so when you want to give the formula, you just take your original angle and put the plus or minus 360 degrees K after it. So on number 1, that would have just been 60 degrees plus and minus 360 degrees K. Okay, let's do couple more examples, I suppose, and then we'll be good. So on number 3, let's start by subtracting 360 degrees. Tells us that one coterminal angle is negative 160 degrees. We can also take 200 degrees and add 360 to it. When we do that, we find out that 560 degrees is also a coterminal angle. And then the formula for finding all of those is to just take 200 plus and minus 360 degrees multiplied with K, where again K just says how many times you had to add or subtract. So let's skip number 4. That's just kind of repetitive. In fact, number 5 is also kind of repetitive. I'll leave those for you to try on your own. So now let's do it for radians. And before we just try to visualize it, in fact, I would say let's not even try to visualize it. Let's just try to rewrite our formula. So for degrees, we took our angle plus and minus 360 degrees K because 360 degrees was one full rotation. For radians, think about what is one full rotation of radians. And the answer to that is 2 pi. So we're going to do kind of the same thing. We're just going to use plus and minus 2 pi in order to figure out our radians and their coterminal angles. So first off, on number 6, we're going to take pi over 4. We're going to use that formula. Let's add by 2 pi. Now, here's what I would maybe think about. Let's convert 2 pi to being a fraction over 4. And 2 pi would be the same as 8 pi over 4. That would probably be an easier way to write this, would be to say take pi over 4 plus 8 pi over 4 is 9 pi over 4. And then you could also take pi over 4 minus 8 pi over 4 is negative 7 pi over 4. There are your 2 coterminal angles. And notice you've got one positive, one negative. And then when you write your formula, you would just say that you were taking pi over 4 plus and minus 8 pi over 4 multiplied with K. All right. Let's do another one. Let's do number 7. So number 7, again, remember we're going to be adding and subtracting by 2 pi. Before we do that, let's rewrite 2 pi as being a fraction over 3. So 2 pi would be the same as 6 pi over 3. So when we are finding our coterminal angles, let's take negative pi over 3 plus 6 pi over 3 would be 5 pi over 3. And then let's take negative pi over 3 minus 6 pi over 3 is negative 7 pi over 3. There would be your 2 coterminal angles. And again, you found those by taking negative pi over 3 plus and minus 6 pi over 3 multiplied with K. Okay, let's do this. Let's skip number 8. 8, you end up using 6 pi over 3 again, so it's pretty easy. And 9, yeah, I mean, if you wanted to, we could work through number 9. For number 9, the only difference is when you write 2 pi, you want it to be a fraction over 6. So that's just 12 pi over 6. Nothing really special with either of those, so I'm going to skip over. Let's take a look at number 10. Number 10 is actually kind of interesting, so I do want to work through it with you guys. First off, let's figure out how we're going to add by 2 pi. So let's rewrite it as a fraction over 4. So we're going to rewrite it as 8 pi over 4. So when we find our 2 coterminal angles, let's start by taking 15 pi over 4 plus 8 pi over 4. It tells us that one possible coterminal angle is 23 pi over 4. And then let's find our negative coterminal angle. So 15 pi over 4 minus 8 pi over 4 is 7 pi over 4. But if you notice, that's not a negative angle. Every other time, we've only had to add or subtract once. This time, we're actually going to have to add or subtract, in this case, subtract twice to get to an angle that's negative. In other words, this would be an example on the bottom here where K was equal to 2, meaning that we subtracted by 2 pi twice, in order to get our negative coterminal angle. So when we talk about K, that's what we're talking about, is how many times would you have to add or subtract in order to get to either a positive angle or a negative angle. And then your general formula for this one, 15 pi over 4 plus and minus 8 pi over 4 multiplied with K. All right, I think that's all I've got for you on this second page of notes. So I'm going to get these uploaded here for you. Have a good rest of your week.